Now let me explain the most important instruction called int. So this is a trap instruction. The role of trap instruction is first raise the previous level to the kernel mode, and then save the registers at the kernel stack, and then looking at the interrupt descriptor table, locate the destination function it needs to jump at the kernel, and it jumps to the destination. Interrupt number for the system core is 0x64 in the toy operating system x86 and 0x30 in Pintas. So when you need to trigger the system core in x86 operating system, you call int0x64. Return from trap instruction turns to the caller of the interrupt handling program. It reduces the previous level back to the user mode. What code to run in trap? It may be completion of disk IO, keyboard interrupt, or system call. So a trap handler is the code to run for each interrupt number. Also, it is called as interrupt handler. There is very important data structure called trap table. It contains the addresses of the trap handlers defined in the system. When system boots, hardware informs the location of the trap table to the operating system. The instruction to inform the location of the trap table is also a privileged instruction. You cannot execute this instruction in user mode. Once you know the location of the trap handler, then you might be able to manipulate it. So it shouldn't be hidden from the user process. While the concept of trap or interrupt looks very simple, it is one of the important invention in computer history. It was first introduced by the computer Atlas, which is the world's first supercomputer with virtual memory and system core. So this is the paper that was published in 1978. It described the system core. So if you're interested, you're welcome to look at this paper. This very archaic computer, this is the picture of Atlas supercomputer. It was developed from 1962 to 1971. This is the excerpt from the Atlas paper. At that time, there is a competition between the U.S. and Great Britain to develop world's fastest computer. Interestingly, at the beginning of the paper explicitly states that Britain was falling behind the United States in the production of high-performance computers. You have to remember that the nation Great Britain was one of the first nation that has first invented computer. The poster you see on the right side of the slide set is the famous movie, The Imitation Game. And Alan Turing is one of the world famous scientists that invented a computer system.
The trap instruction is used to properly adjust the privilege level when the user process requests for the kernel service. Let me explain the control flow of the process execution under the limited direct execution.
At the booting, operating system has to initialize a trap table. When you execute a user program, you do the same thing. You create the entry for the process list and allocate the memory for the program and load the program into memory and set up the stack with arguments and then initialize the registers. And it performs return from trap. In the limited direct execution, there is a clear privilege difference between operating system and user program. When you want to use the service provided by the operating system, you have to call explicitly an instruction called trap. Once operating system finishes doing some work for the user program, it calls return from trap function or instruction, return from trap. What return from trap instruction do is restore the registers from the kernel stack and move to the user mode and jump to main. You should remember that single instruction return from trap takes care of all these steps. Let's look at the important part of the program. Now it starts a new program and it jumps to main. Then it starts to instruction one by one. And at some point, let's assume that it needs to make a system call. Now it triggers a trap instruction and go into the kernel. Then, in the course of calling trap, it saves the register to the kernel stack, and then it moves the mode to the kernel mode, 2, and it jumps to the trap handler, 3. Remember, all these steps are executed in a single instruction called trap or int. And then once the control is transferred to the operating system does all the works for the trap, do the system call, and then it calls return from trap. Then return from trap instruction restores the registers from the kernel stack, move the user to mode, and jump to the PC after trap. And then after returning from the trap, user program finishes executing its own instruction.
Finishing user process, the user process calls exit system core.
And exit is a system call that requests the operating system to clean everything up for a given process. And then the control transferred to the operating system, and operating system accepts trap and then do the system call associated with exit. It does two things. First, it frees the memory process, and then it removes the process list. It removes the entry from the process list.